In a closing factory, the time taken by machines to manufacture a certain type of shot are assumed to be normally distributed with a mean of 44 minutes and standard deviation of 4 minutes. Question 8. Determine the value of t if 10.56% of the shots take more than t minutes to be manufactured. So it is given that a random variable, let it be t or it may be x, it doesn't matter, is normally distributed with parameters. Mean is 44 and standard deviation is 4, but here we write variance. Variance is standard deviation squared, so we can write 16 or just 4 squared. And it is given that probability that this random variable t is greater than some value of t which should be found, and this probability is equal to 0.1056, and check, you can see that it's 10.56% as required, and it means that we should find some value of t so that area to the right is equal to 0.1056, and using a calculator we choose inverse normal, and my calculator asks me the area to the left, so I should answer 1 minus 0.1056, and mu and sigma are given, so mu is 44, sigma is 4, and we can find this value of t directly without using standardized normal distribution, without z, and so on. So you can see that it's 49.0, so the required value of t is 49.0 minutes. The next, find the probability that a shot picked at random took between 42 and 51 minutes to manufacture. So we need just probability that value of t is between 42 and so greater than 42 and less than 51. Included, excluded, it doesn't matter, because for normal probability at a point is 0. And it is equal to, so mu sigma given, so we can just calculate it directly and choose normal CDF from 42 to 51, mu is 44, sigma is 4, and we get that it's 0.651 significant figures. Question C. If a shot took less than 45 minutes to be made, calculate the probability that in fact took more than 42 minutes to make. It's not given clearly, and we know that given indicates directly that it's about conditional probability, but you should guess or understand that it's about conditional probability. And what is probability and what is given? So we need probability that time is greater than 42 given it is less than 45. And just applying the formula for conditional probability, there should be what? And in the numerator, so probability and time is greater than 42 and less than 45, so we can write that it's just time which is greater than 42 and less than 45, and divided by this given, probability of this given, so it's probability that t is less than 45. And it is equal to So it's again we choose normal CDF, lower 40 to upper 45, under the same mu is 44 and the sigma is 4, this value, and divided by again distribution normal normal CDF and less than 45, so lower is for example negative 100 or 1000. In general it's negative infinity, but it decreases very rapidly, so 100 negative 100 or negative 1000 it's enough, and upper 45 and same, and we get that it is equal to 0.485 to 3 significant figures. The next, the owner of the factory believes that the mean time is greater than 44 minutes due to the aging machinery. He finds that the mean manufacturing time of a random sample of 4 shirts to be 47 minutes. Question D, by clearly stating suitable hypothesis, test at 5% significance level the owners believe. So the null hypothesis is that mean time is 44, and the alternative hypothesis here we can see that is greater, so mu is greater than 44. And to test these we use what? A sample, a random sample, and this random sample T or X, it doesn't matter, is normally distributed with parameters. It's the same mean, but new variance, or it's not actually new, it's variance for sample mean. For sample mean, it's the previous variance, which is 4 squared or 16, and divided by n, and n is 4 here, and you can see that it's just 4. And under this distribution we should calculate probability that sample mean is what? Since we test for greater, we should calculate sample mean to be greater than this value, 47, and it's called actually p-value. And just using a calculator, and normal CDF, lower 47, upper, it's in general plus infinity, but 1000 it's enough, and the mu 44, but sigma, it's 4 is variance, and standard deviation square root, so it's 2, not 4. And we get that it is equal to 0.066800668, and then we compare this with significance level 5%, and actually it will be the result of our test. It will be a conclusion. So since as 0.0668, and we compare with 5%, 0.05, and if it's less than 5%, we accept the alternative hypothesis or we reject the null hypothesis, but here it's greater than, so the there is no significant evidence to reject H0. Or in context, what does it mean? It means that there is no significant evidence that the mean time has increased, or there is no significant evidence to support the owner's belief that mean time has increased. No significant evidence to reject H0, it means that we accept H0 or we reject H1, alternative hypothesis. And that's all for this question.